everyone. So this is the definition of geometric sequence and geometric series. A geometric sequence is a sequence of number in which the ratio between consecutive terms is a constant. The formula for the n term of geometric sequence is a sub n equals a sub 1 times r raised to n minus 1, where a is the first term and r is the ratio. A geometric series results from adding the term of a geometric sequence. The formula for the sum of finite geometric series is S sub n equals a sub 1 times 1 minus r raised to n over 1 minus r. And the other one is the formula for the sum of infinite geometric series is S infinite a sub 1 over 1 minus r. So here's the first example of geometric sequence and series. Let's find the sum of geometric sequence 4, 8, 16, and 32. The first thing we need to do is let's find the common ratio, which is a sub 2 over a sub 1. So itatranspose natin to 8 over, ang a sub 1 natin ay 4. So pag dinivide natin to sa itong dalawa na to ay magiging 2 ang sagot. So, yan. After naman nun, ay hahanapin natin yung infinite niya. Kasi, let's find the sum daw. So, ang gagamitin nating formula is yung sa infinite. Equals a sub 1 over 1 minus r. So, the next term is ililipat natin yung a sub 1 again at saka yung value naman ng r. So, 4 over 1 minus, ang value ng r natin ay 2. And, after nyan, ano lang natin to. Tapos yan. Negative 1. Kasi 1 minus 2 is negative 1. And then, kapag pinag-divide natin itong dalawa, magiging sagot dito is negative 4. So, here's the final answer.
So now, let's try our other examples of geometric sequence and series. So our given example is, find the sixth term and the sum of the geometric sequence of 5, negative 15, 45, and negative 135. So first, we need to identify our givens, which is the negative a sub 1 is equals to 5. Is that's our first term. Our nth term is equals to 6, because that's what we're finding. And our common ratio, to be able to find our common ratio, we need to a sub 2 divided by a sub 1. So is equals to, substitute the givens, is a sub 2 is negative 15 divided by 5, which is the a sub 1, is equals to negative 3. So that's our common ratio. So next we need to find our a sub n. A sub n is equals to a sub 1 times r raised to n minus 1. Substitute the given, a sub 1 is 5 times our common ratio, negative 3, raised to n is 6 minus 1 is equals to, copy the 5 times negative 3, copy the negative 3, and 6 minus 1 is 5 is equals to 5, copy the 5, and negative 3 raised to 5 is negative 243. And 5 times negative 243 is equals to negative 1,215. So that's our a sub n. So next we need to find our sum of the sixth term, which is S sub n is equals to a sub 1 times r raised to n minus 1 over r minus 1 equals, substitute the given, a sub 1 is 5 times our common ratio, negative 3 raised to 6, because that's our answer, minus 1 over our is the negative 729 minus 1. Keep, change, name, plus, and change. Make it negative 1. So it's equals to negative 729 plus negative 1 is negative 730. That's how we get this. Then, negative 3 minus 1 is negative 4 equals to 5 times negative 3. So 5 times negative 730 is equals to negative 3,650 divided by negative 4 is equals to 912.5. So this is the answer of the sum of the geometric sequence. Here's our example for geometric sequence in series. Find the sum of the fifth term of the given 3, 6, 12, 24. So in order to find the common ratio, we need to divide a sub 2 to a sub 1. So 6 over 3 is equals to 2. And our end term is 5. So our general formula is a sub n equals to a sub 1 times r n minus 1. So to solve, we need to substitute the given our formula. So a sub 1 is equals to 3 times r is 2 and Rm is 5 minus 1. So the first thing to do is solve the exponent. So 2, 5 minus 1 is equals to 4. Then solve the 2 raised to 4. So 3 times 2 raised to 4 is equals to 16. So the last thing to do is multiply the 3 to 16. So 3 times 16 is equals to 16 times 3 is equals to 48. So our fifth term to the given 3, 6, 12, and 24 is 48. After getting the fifth term, next we need to find the sum of the fifth term. So here's our formula. S sub n is equals to a sub 1 r raised to n minus 1 over r minus 1. So this is our formula for finding this. Next, substitute the given to our formula. So a sub 1 is equals to 3 times Rn is 2 and over 5 minus 1 over R 2 minus 1. So after substituting the given to our formula, we need to solve for the exponent. So 3 times 2 raised to 5 is equals to 32. 32 minus 1 over 2 minus 1 is equals to 1. So next, we're going to subtract. So 3 times 32 minus 1 is equals to 31 over 1. So 3 times 31 is equals to 93 over 1. So or 93. So this is the fifth term of the given. So therefore 93 is our sum of the fifth term. So let us first define what is arithmetic sequence and series. An arithmetic sequence is a sequence of numbers such that the common difference between each consecutive term is a constant. while the arithmetic series is the sum of the terms of the arithmetic sequence. So let's try our first example of arithmetic sequence and series. Here's our given example. Find the 9 terms of 5 plus 8 plus 11. So let us first identify the a sub 1. So our a sub 1 is equals to 5 because that's our first term. And second is the common difference. Our common difference is, to find our common difference, we need to subtract the a sub 1 to a sub 2. So a sub 2 minus a sub 1 is substitute the given 8 minus 5 is equals to 3. So that's our common difference. And our nth term is equals to 9 because that is the term that we're finding. And after that, S of n is equals to question mark because it's still pending. So let us solve the a sub n, which is, and this is our general form. A sub n is equals to a sub 1 plus n minus 1 times d is equals to, our a sub 1 is 5 plus our nth term is 9 minus 1 times 3, our common difference, is equals to 5, copy, and 9 minus 1 is 8 times 3 is equals to 5, copy again, and plus 8 times 3 is 24, and 5 plus 24 is 29. And that's our a sub n. So now, we will solve the s sub n. So, s sub n is equals to n times a sub 1 plus a sub n divided by 2 equals, our n term is 9 times a sub 1, 5 plus our a sub n is 29. 29 divided by 2 is equals to 9, copy the 9, and 5 plus 29 is equals to 34 divided by 2 is equals to, copy the 9, and 34 divided by 2 is equals to 17, and equals 9 times 17 is equals to 153. So this is our answer for finding the 9 terms of 5 plus 8 plus 16.
So here's an example of arithmetic sequence. The given is, find the sum of the first 20 multiples of 8. 8, 16, 24, and 32. So ang given ay a sub 1 is equals to 8. Then n is 20. Then ang common difference ay magiging 8 kasi 16 times 8 is 8. Then ang s sub 20, so ano is a sub n is equals to a sub 1 plus n minus 1 times d. So ang gagawin natin dito ay substitute lang. Ang magiging a sub 20 kasi ang value ng n ay 20. A sub 20 is equals to 8 plus n is 20. 20 minus 1. Then ang d is 8. So isa-solve na natin siya ng a sub 20 is equals to, i-bring down lang yung 8, ibababa. Then 20 minus 1 is 19 times 8. So a sub 20 is equals to, ibababa ulit ang 8. 8 plus 19 times 8 is 152. 152. Then a sub 20 is equals to 8 plus 152 is 160. So ito ang final answer. So after nyan, magpuproceed tayo sa 20 multiples of 8. Magiging
S sub n is equals to n a sub 1 plus a sub n divided by 2. So, ito ang pinaka-general formula. Then, katulad ng gagawin natin dito, yung ginawa ulit natin dito. So, magiging S sub 20 is equals to n ay 20. Isa-substitute lang ulit. A sub 1 is 8 plus 160 divide 2. So, S sub 20 is equals to 20. 8 plus 160 is 168 divide 2. Then S sub 20 is equals to 20. 168 divide 2 is 84. So 20 times 84 is 1,600. So here's the final answer. So here's a second example of arithmetic sequence. The given is find the next term and the fifth term of arithmetic sequence of 3, 6, 9, 12, 15. So this equals to a sub 2 minus a sub 1. Isa-substitute lang dito. A sub 2 is 6, then a sub 1 is 3. So 6 minus 3 is 3. So a sub n is equals to a sub 1 plus n minus 1 times d. Ito ang pinaka-general formula. So, isa-substitute lang ulit natin. A sub 5 is equals to 3 plus 5 minus 1 is equals to 3. So, a sub 5 is equals to, ibababa ang 3. 3 plus 5 minus 1 is 4. 4, then copy the 3. So, a sub 5 is equals to 3. Ibaba ulit. 3 plus 4 minus 3 is 12. Then, a sub 5 is equals to 3 plus 12 is 15. So, next is the next term na an plus b. So, here's the general formula. Then, and next term is equals to 15 a sub n, and the distance plus 3. And term is equals to 15 plus 3 is 18. So, here's our final answer.
Today, we will be solving an equation regarding the arithmetic sequence. And the first problem is find the sum of the 63rd term of the arithmetic sequence, negative 19, negative 30, negative 7, and so on. We would be looking for the value of a sub n and the s sub n. And the value of a sub 1 is negative 19, and the value of n is 63. We would be looking first for the a sub n, and we would be using the general equation, which is a sub n is equals to a sub 1 plus n minus 1 times d. We would be substituting the value of a sub n to n, and it would be a sub 63 is equals to a sub 1, which is negative 19, and bring down the positive sign to the quantity of n, which is 63 minus 1 times the value of common difference is 6. We will be bringing down again the a sub 63, negative 19, and the positive sign, and we will be computing for the 63 minus 1, which is 62, times 6. We will be bringing down again the a sub 63, negative 19, and the positive sign, and we will be computing for the 62 minus 6, which is 372. Next, we will be bringing down again the value of a sub 63, we will be solving now for negative 19 plus 372, which is 353. And there you have the value of a sub n. Now we would be looking for s sub n, and we would also be using the general equation, which is n is equals to n times the quantity of a sub 1 plus a sub n divided by 2.
Divided by.
We would be substituting the value of n to Sn and n, which is s sub 63 is equals to n 63 times to the quantity of a sub 1, which is negative 19, plus to the value of a sub n, which is 353. And we would be bringing down the denominator. We would be copying again s sub 63 is equals to 63. The quantity of negative 19 plus 352 is 334 divided by 2. Then we will be bringing s sub 63 equals to 63. Then 334 divided by 2 is 167. Now we will be computing for 63 multiplied to 167. So copy the s, 63, and the answer will be 10,521. And there you have the value of s sub n. Now we will be putting the value of a sub n here, which is 353, and the value of s sub n, which is 10,521. And that's the answer for our first problem on the equation of the arithmetic sequence. Now let us proceed to the second problem for our arithmetic sequence, which is find the sum of the 12th term of the arithmetic sequence 11, 15, 19, 23, 27, and so on. Now, first, we will get the common difference, which we would be subtracting the second term and the first term, which is 15 and 11. 15 minus 11 is equals to 4. So our common difference is 4. We would be looking for the a sub n and the value of s sub n. The value of our a sub 1 is 11. The value of our n is 12. For us to get the value of a sub n, we would be using the general equation, which is a sub n is equals to a sub 1 plus to the quantity of n minus 1 times the common difference. Now we would substitute the value of a sub n and a sub 1, which is a sub 1 is 11, plus the value of n is 12 minus 1, and we would substitute the value of difference, the common difference, which is 4. Now it would be a sub 12 equals to 11 plus the quantity of 12 minus 1 is 11 times 4. A sub 12 7 plus 11 times 4 is 44. For us to get the value of a sub 12, we need to add 11 plus 44, which is 55. So the value of our a sub n is 55. Now, for us to get the value of s sub n, we will be also using the general equation, which is s sub n is equals to n times the quantity of a sub 1 plus a sub n divided by 2. And we would also substitute the value of n, which is 12, and so on. Substitute the value of a sub 1, 11, plus the value of a sub n, 55, divided by 2. Then copy again. B. 11 plus 55 is 66. And then copy the denominator, which is 2. S sub 12. That's 12. Now, 66 divided by 2 is 33. Then for us to get the value of S sub n, we would multiply 12 and 33. So 12 times 33 is 396. Now we will be putting the value of A sub n, which is 55, and the value of S sub n, which is 396. And that's how you get the value of A sub n and the value of S sub n in an arithmetic sequence.
Here is another example of arithmetic series and sequence. So let's find the 12th term of the arithmetic series 3, 8, 13, and 18. The first thing we need to do is let's find the common difference, which is A sub 2 minus A sub 1. So let's substitute. Our A sub 2 is equals to 8 and our A sub 1 is 3. So kapag pinag-minus ang dalawang to, ang magiging sagot natin ay 5. So ang ating common difference is 5. So the next one is the 12th term kasi 12th term ang ating hinahanap. So ang formula dito ay A sub n equals A sub 1 plus n minus 1 times the common difference. So let's substitute. A sub n equals our A sub 1 is 3 plus our n is 12 because it is the 12th term. 12 minus 1 and our common difference is 5. A sub 12 equals the first thing we need to do is yung mga nasa parenthesis muna. So 3 plus 12 minus 1 is equals to 11. And then 5. Copy lang natin yun kasi copy lang ulit natin. Tapos yung nasa parenthesis ulit yung ating isusunod. So 11 times 55 is equals to 55. And then A sub 12 is equals to, ipag-add lang natin yung dalawa na to. So 58. So our A sub 12 is equals to 58.